Hello everyone, welcome to CodeChef. Myself Jolacharas here, and today we are going to solve the problem which came into starters 206. The name of the problem is PRIMESUM and the problem code is PRIMESUM7. The difficulty rating of the problem is cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem says chef has an integer array A of length 10 such that A of I lies from 1 to 3. Chef is wondering how many pairs exist in his array which have a prime sum. Formally, find the number of pairs I, j such that ij lies from 1 to n and a of I plus a of j is prime. X is a prime integer if it is not 1 and has no other divisor except 1x. For example, 2, 13 and 19, 7 are prime integers while 1 and 4 are not. Input format. The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of multiple lines of input. The first line of each test case contains a single integer n. The second line contains n integer a1, a2 till a of n. Output format. For each test case, output on a new line the minimum number of pairs with prime sums. Constraint for t lies from 1 to 100, for n lies from 1 to 100, for a of I lies from 1 to 3. So guys, now let's understand the sample test case in the question more precisely over here. So guys, this question is pretty much straightforward. It says that chef has an integer array of length n such that a of I lies from 1 to 3, basically all the integers in that array. Chef is wondering how many pairs exist in his array which has a prime sum. Okay, when you sum two integers, their sum should be prime basically. So you have to find such number of pairs. Yeah. So you know that x is a prime integer only if it is not 1 and has no other divisor except 1 and itself. Okay. So for example 2, 13, 19, 7. Okay, so you have to find the number of pairs I comma j such that. Cool. So okay, so if you will go over here, you are given an input. Okay, so you will be given the number of the arrays also. Okay, so let's go over here. Cool. So you are given n and the elements in the array. Okay, so in for the first test case, if you will see over here, the valid pair is 1 comma 2 which has a sum of 2, right? So basically 1 comma 2. Okay, I will make a pair. So the valid pair over here is for the first test case would be 1 comma 2, and where if we do which has a sum of 2, right? So the output is simply 1. Okay, so I think this is clear. Now let's go for the other test case, guys. Okay, let me see over here. Okay. Mm, okay, I've got n. Okay, cool. So next, let's take the another test case. Okay. Mm, okay, for the second test case from here, we've got total in 3 elements in the array. Okay, so from the 3 elements in the array, okay, so the valid pairs are, first I will add the first valid pair which is 1 comma 2. Okay, and the other valid pair could be 1 comma 3. So basically they have an individual having sum of 3 and 5, right? So 3 and 5. So yeah, so total 2 pairs can be formed, right? So output is simply 2. So guys, I think the test cases are pretty much clear. Simply you have to find the number of pairs where the some elements some are having prime. Okay, so guys, I think this is very much clear. Okay. uh, okay, so now let's move toward the simple solution. So the array elements are in 1 comma 3, so there aren't that really options for what the sum of two of them can actually be. In fact, the sum must be an integer in range 2 to 6, right? So you know that a of I lies from 1 to 3, right? Not more than that. So the options reduces, so this is a good for us. So the only prime in the range 2 comma 6 are 2, 3, 5. So our aim is to count the number of pairs of elements whose sum equal one of these three values. There are now two ways to solve this problem, right? So we have used the fact that n is lesser than or equal to 100, so that O of n square is fast enough, and this allows us to simply iterate over each pair of elements and check if the sum if 1 of 2 comma 3 comma 5 are not solving the problem. A faster solution is to observe that the only way to obtain a sum of 2 is via 1 plus 1, the only way to obtain a sum of 3 is via 1 plus 2, and the only way to obtain a sum of 3 is via 2 plus 3. So if or 1, okay, so if C1 plus if C1, C2, C3, so this is for 5, okay, cool. So if C1, C2, C3 are the counts of 1, 2, 3, the array respectively, there are C1 times C2 ways to choose a pair of 1, comma 2 whose sum is 3, and C1 ways to choose a 1 and C2 ways to choose a C2. There are C2 times C3 ways to choose a pair of 2, comma 3 whose sum is 5, right? So there are C1 times C1 minus 1 by 2 ways to choose a pair of 1, comma 1 from a distinct indices whose sum is 2, right? So the answer is hence the sum of these three quantities. The second solution runs in O of n times, since it only requires the computation of the values of C1, C2, C3. Right. So this is simple observation, guys, simple ad hoc solution. So I guess this is very much clear. Now let's move toward the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as my array. I made a frequency array of 4, 0, okay, and I did my following operation over here and getting my answer printed. And as you can see that, guys, I have got my C++ code right. Now let's move to the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as my n as well as my array and my frequency array. Okay, I'm storing all the frequencies, and the last I'm simply printing my answer by doing this operation. Yeah. So guys, I think the solution is pretty much clear. Now let's meet in the next video. Thank you so much, guys, for watching our videos.